All right, welcome back to the Explainer. So, we've spent a massive amount of time digging into the engineering, the construction, and the installation of floating LNG facilities. And at this point, we have this colossal, fully built structure sitting out in the ocean. But, right now, it's really just cold steel. So today, we're tackling the absolute climax of this whole process. How on earth do you safely wake this mega facility up? Let's dive right into FLNG commissioning and startup. 12 to 24 months. Just let that sink in for a second. That is the staggering amount of time it takes just to transition from the end of physical construction to actual live operations. Because, well, you don't just flip a giant switch when the last welder packs up. This is a high-stakes, meticulously planned phase where the entire facility is systematically brought to life piece by piece. Which brings us to the multi-billion-dollar question. How exactly do you safely wake up an offshore facility of this scale? The short answer? Very, very carefully. On an FLNG, literally every single valve, every sensor, every control loop, and every safety system has to be completely and exhaustively tested. We have to prove they are 100% safe before even a single drop of live hydrocarbons enters the system.
Here is our roadmap to first gas. We'll kick things off with the commissioning philosophy, then get into the pre-commissioning grunt work. From there, we'll map out the utilities and process sequencing, hit the climax with first gas and startup, and finally wrap up with the handover.
All right, Section 1, Commissioning Philosophy, from mechanical completion to RFSU. Because an FLNG is so impossibly huge, you have to break it down and test it in logical, functional chunks, like taking the cooling water system as its own separate unit. And every single system goes through a rigid, four-step progression. First is mechanical completion, which just means construction is physically done. Second is pre-commissioning, proving it's mechanically ready. Third is commissioning, where we do functional testing with utilities, but absolutely no hydrocarbons yet. And that leads us to the Holy Grail, RFSU.
So, RFSU, ready for startup. This is the big milestone, proving a system is functionally sound and completely safe to take on real process fluids. Now, keeping track of this across hundreds of distinct systems is a mammoth task, so everything is strictly logged in a CMMS, a computerized maintenance management system. Any little defect they find, it's logged as a punch item. You've got your A punch items, which are total showstoppers that absolutely must be fixed before RFSU, and then your B punch items. Those are minor quirks that we can safely sort out after startup.
Moving on to Section 2, Pre-commissioning grunt work, the micro details.
To guarantee the safety of the whole facility, we have to zoom way in on the micro details, starting with the piping. Every inch of pipe has to be flawlessly cleaned before process fluids go in. We're talking about flushing out all the construction debris, weld spatter, mill scale, dirt, the whole shebang. They use high-velocity water flushing for most of it, but for supercritical systems where water is a strict no-go, they'll use an air blow or chemical cleaning. Once it's completely clean, every pipe gets pressure tested. Usually that's a hydrostatic test at 1.5 times the design pressure, or a pneumatic test using nitrogen for the really sensitive stuff. And of course, every single step is strictly documented and witnessed by the owner's inspector and a class society rep.
Tens of thousands. That's how many individual instrument loops are on an FLNG. And yep, every single one gets checked manually. This loop check verifies that the signal from a transmitter out in the field actually shows up correctly on the control room display and that the controller's output truly operates the final device, like a valve or a motor. Testing tens of thousands of these loops, it literally takes months of intense, highly focused manpower.
But hey, it's not just the basic instruments we're checking. It's the ultimate safety net. Safety Instrumented Systems, or SIS, have to be thoroughly proof-tested before we hit RFSU. We're talking emergency shutdowns, fire and gas detection, and high-integrity pressure protection. The team essentially has to fake a crisis. They simulate a trigger at the field sensor and watch to ensure the intended effect, like a massive shutdown valve closing or a compressor tripping, actually happens and happens perfectly on time. Everything must rigorously match the safety requirement specification under the IEC 61511 standard, no exceptions. Next up, Section 3, Utilities and Process Sequencing. Waking up the ship. You can't just power up everything at once. Turning these systems on requires a strict, non-negotiable chronological sequence. Utilities always come first. Step 1, you absolutely must prove the emergency generator and UPS. Why? Because they power the safety systems that have to be alive before anything else turns on. Step 2, main power comes online. Diesel or gas generators are progressively loaded and switchgear protection is verified. Step 3. Instrument air and nitrogen. We commission the air dryers to ISS specs and get the nitrogen systems ready for essential purging and blanketing. And Step 4. Cooling water and steam. Pumps kick on, flow gets distributed, heat exchangers are checked for leaks, and boilers are lit off. So the big takeaway here is that only after those utilities are fully awake can you start commissioning the process systems. And again, there's a strict order here too. Produced water treatment has to be ready first to handle any aqueous phases. Then, crucially, the flare and blowdown systems. Pilots are lit, ESD connections are verified. This is the facility's last line of defense, guys. It absolutely must be proven before any hydrocarbons show up. After that, we charge the amine acid gas removal unit, dry out the molecular sieve beds, and carefully leak test the refrigeration system with nitrogen while slowly cooling the heat exchangers to avoid thermal shock. Finally, the LNG cargo tanks are cooled down with an LNG spray and the cryogenic pumps get tested.
Which brings us to Section 4, First Gas and Startup, the climax. This is the moment. With RFSU fully achieved across the board, real hydrocarbons from the subsea wells flow into the facility for the very first time. But it's not a sudden rush, it's a highly choreographed timeline. Day 1, you crack open just one subsea well. Week 1, you focus entirely on stabilizing that gas in the inlet separator. Week 2, the amine system finally comes on stream with the real gas. Week 3, you switch the molecular sieves to duty. Week 4, the refrigeration system is progressively loaded up. It is an incredibly slow, methodical process, so much so that the first commercial LNG is actually produced and loaded onto a carrier months after that initial first gas milestone.
Okay, time for a quick reality check though. Commissioning is never, ever perfectly smooth. Equipment trips unexpectedly, control loops constantly need retuning, instrument calibrations drift. The dedicated commissioning teams, the process engineers, the instrument techs, rotating equipment specialists, and safety engineers, they are working grueling, extended shifts to troubleshoot, investigate, document, and safely fix every single deviation before any system goes back into service.
And finally, Section 5, Handover and Course Wrap-Up. We finally reached the ultimate milestone, beneficial operation. This means the facility is steadily producing LNG with proven, safe control. But crossing this finish line requires checking a lot of vital boxes. The operations team must be fully trained and their competency demonstrated. All operating procedures have to be completely written and approved. Critical spare parts must be heavily stocked in the warehouse. Preventative maintenance schedules are locked into the CMMS. The permit to work and management of change procedures are fully operational, and emergency response procedures have been proven in real-time live drills. Once all of that is checked off, the operator officially takes the keys for a 25-year production run that makes this entire multi-billion-dollar investment worth it.
Wow, what a journey it's been. Let's just take a quick second to look back at the sheer amount of ground we've covered in this series. Across 10 modules, we learned how FLNG unlocks stranded offshore gas. We traced the entire process train, compared liquefaction tech, and dug into critical equipment like the main cryogenic heat exchanger. We tackled unique marinization challenges, navigated complex design standards and procurement strategies, and explored the massive construction and hull integration phases. We pulled it all offshore with marine installation, and today we finally brought the whole thing to life through commissioning.
I really want to thank you for coming along on this deep dive into floating LNG engineering. So now I want to hear from you. Out of all 10 modules, which one did you find the most insightful? Let me know down in the comments. If you got value out of this explainer, please subscribe and share it with your industry colleagues. We've got an upcoming series that'll cover FLNG operations, maintenance, and troubleshooting, so definitely stay tuned for that. But before we sign off, I'll leave you with this thought. As technology advances at warp speed, how much of this intensely human-driven commissioning process do you think will eventually be handed over to AI? Definitely something to chew on. Until next time, stay safe offshore.